like where should the numbers come from? Something like this, like 1, 2, come from. So where would 1, 1, 1, 1, 0, 1
So there was a question about where these numbers come from in the matrices, and this is highly problem specific. It depends. I mentioned multilinear algebra, and that links to linear algebra. So have any of you seen linear equations? I know those that have studied the matrices and matrix multiplication will have seen linear equations. But the rest of the people here, do you know what a linear equation is? Okay. So maybe that's the starting point. This is just me being more considerate to the video than to the audience. So if you have a problem seeing anything, shout at me. Right, so I think that will work fine. You can always zoom in later. That's a linear equation. That's a linear equation. Can everybody see that? Right, what makes it linear? The power's 1 with the variables. Okay. This is a linear system. So you want to know where the matrices come from? This is one way. Right. So this is where you can get your numbers from when you're working with equations. But of course, with the Kronecker product features, this is not commonly the systems that we work with. It's things like, for example, economic data, where you've already collected, on this date, this was the exchange rate like I showed in the beginning. If you collect a lot of data like that, that would form a matrix. And where Kronecker products are particularly effective is when you have lots of information like that. Remember, the Kronecker product takes small matrices and makes bigger matrices. So there, it's up to you how you obtain the numbers in a sense, right? So here, this is the mathematical construction, and of course, every matrix can take us back to a set of linear equations. So if we have this matrix, all we need is two variable names. What we call them doesn't actually matter. The right-hand side, we can either omit or give explicitly. If we omit it, we normally mean that it should be 0. And then we can reconstruct these equations just by knowing these coefficients. But in reality, what you do with the Kronecker product is it's applied to, there's a variety of options. Let's say images. Where does the image come from? It's from your camera. Right? It's not data that comes from a mathematical system. It's merely the representation of something else. And this is most of the time what we do if you're working with data analysis via matrices. The information, the numbers are coming from some external application, economic data or picture data, or like when I was talking about the epileptic diagnosis that they do. This is sensors, electrical sensors that they have, and all the I'm not sure what it is, but let's say it's the voltage that they measure, and it's all the voltage values that they store in an array. And so that's where the numbers come from. Does that answer the question adequately? Does everyone understand? Are they satisfied? Okay. Right, so let's try. must have just used the right symbols. Alright, so this is also set up. Everything is 3 entries, so it should be easy. And I'll give you one hint, don't do too much work. You can save a lot of work here. So at least a number of you know how to do the ordinary matrix multiplication.
Just a 3 by 3 matrix of 14.
So just repeat that, 3 by 3 matrix?
Of 14.
Right. And how did you get that?
Well, the product is going to be constant.
Right, so you get the same product every time. And why does that happen? It's because you have right? So this matrix here is the outer product of 1, 1, 1 with 1, 2, 3. And this matrix is the outer product of 1, 2, 3 with 1, 1, 1. And this gives us then the inner product of these 2 matrices, which is going to be 1 times 1 plus 2 times 2 plus 3 times 3, which is the 14 that you got, followed by the outer product right, but I guess you did it with ordinary matrix multiplication. So can you see? Right, of course all of these examples you can do with ordinary matrix multiplication if we're doing the outer product examples. Let's do one with the Kronecker product. First, I'll wait for you so I can erase it. Not much board space and I waste a lot of it. Does it make sense? Should we do another matrix product and then a Kronecker product? Okay. Can I erase this one? At this point I usually ask for favorite numbers, but then maybe I can't multiply it, so I shouldn't take the chance. Right, so again this is a, I should have chosen that better. Well, we can do this, but it's going to be ugly. So this is going to be, here we can use any decomposition, so let's maybe see if there's something a bit more exciting.